Introductions. My name is Chris. I'm on the sales engineering team here at Formlabs. Today, I'm accompanied by Sam McBride, the 3D lab manager at Legacy Effects. Today, I'll go through a bit of an intro, and then Sam will go through most of the presentation content is going to be combining MJF and SLS 3D printing at his company. Lots of cool parts, lots of big names out there, so I'm curious and super excited to see all that he has to go through. As information is given out, obviously there will be questions. So just to familiarize yourself with the setup, there is a chat function and a Q&A function. I will leave general chatter in the chat area, and then questions that you want answered at the end will get compiled, and then we'll have maybe 15-20 minutes at the end of the hour here and make sure all of those questions are answered. So rough agenda. I'll give an introduction to Formlabs and a bit of Legacy Effects. We'll go over why powder bed 3D printing at Legacy, and then some cool applications, and as mentioned earlier, the Q&A at the end. So for those that are not familiar with Formlabs, Formlabs is a 3D printing company. We manufacture the hardware, software, and materials. In the picture below, you can see the currently latest and greatest ecosystems that we have to offer. We have two core technologies. Our Form 1 back in 2012 from our Kickstarter has obviously evolved into a Form 4 and some larger versions under the stereolithography technology scope. And then we also launched a SLS, or selective laser sintering ecosystem, with the Fuse 1 Plus being the printer. The Fuse Sift is your recovery station, and then the Fuse Blast is the clean it all, one-stop shop. Formlabs by the numbers, as I mentioned, we were started in 2012. Since then, we've grown over to a little over 130,000 printers being shipped. That is the highest install base when it comes to professional 3D printers. With those 3D printers, we have quite a variety of materials, 40+ materials that we produce in-house. And we've also released a open material mode, so we do allow for third-party materials to run on it as well. Our main focus is efficient, reliable printers. And so with that, we are able to produce over 300 million parts from our printers, which is a crazy high number. And we also have a strong workforce, 800+ employees, and quite a few technologies that we have developed. We are a global company, so I am situated in our headquarters just outside of Boston. We do have remote offices in Milwaukee, Ohio, and then overseas we have a few offices in Budapest, Berlin, and then a few in APAC. We work with a lot of customers, anywhere from the mom and pop shops to Fortune 100, 500 companies. Obviously, our focus today here is going to be Legacy Effects. Just one more overview. So SLS is our main focus today. For those that need a quick little refresher, SLS is going to be utilizing your usually nylon powder. We're heating up that powder using some form of blazing system, extra heat, just to take that powder over its melting temperature, so it will sinter, harden, and get your parts. Formlabs does have SLA. It won't be the main focus, but it may come up. And then FDM, I know Sam has a little bit of FDM in his shop, which may go over. That is your standard kind of core XYZ filament extrusion. As different technologies have different materials, that also lends to different use cases as well as capabilities. So FDM generally lends itself into the hobbyist and basic prototyping. SLA, as you get into more high temp, more ductile materials, that leads you to a wider variety, thinking like low volume molding, functional prototypes, medical models. If you're looking for any sort of biocompatible certification, that works well. And then SLS with the throughput, or MJF, will allow you to get into full production parts, which is obviously a whole nother beast in and of itself. So with that being said, my job is done here. I will see you at the end for the Q&A. I would like to introduce Sam McBride and take it away.
All right, so yeah, I run the 3D printing lab at Legacy Effects. We're a practical effects company where we make, the physical and practical special effects, whether it's creatures and monsters, things like that for movies and film. Some of our more notable ones were that we created the original Iron Man. More recently, we created the Mandalorian, the Baby Yoda creature, the Fallout suit from last year, the big power armor. So yeah, that's what we do. We create anything from small to massive practical effects, and that right now is largely through a workflow that goes from digital to 3D print, some sculpting, and then we have different departments such as mold, paint, etc. And it all comes together to make the effects you see on screen. So I'm gonna today talk you through how 3D printing, specifically our SLS on our Fuse 1 Plus, helps us enable that. Um, so in-house at Legacy Effects, we had FDM printing for a long time, um, as well as a little bit of SLA printing. And originally that was very slow and time consuming. And as we upgraded our fleet, at some point, we made the leap to getting into powder printing with HP's MJF technology. And MJF technology enabled us to do supportless geometries, and enable us to do batch printing of parts. And most iconically for us, it allowed us to make functional mechanical parts, which for us is a big deal as we do animatronics as well. And those parts internally, if we were doing it the traditional way, all has to get milled with aluminum or metals. And now we can just 3D print very robust nylon parts on a powder-based printing without any worry of supports, minimal cleanup. So powder printing kind of changed the whole game for us for how we 3D print it. Um, so kind of how we use each technology varies. So FDM is really good if we're doing small, just test prints. Often you'll see whole creatures, for example, the xenomorph we made for the movie Alien. There is an entire FDM printed one somewhere around because before we make the final parts, we like to do everything out of FDM just to make sure that it all comes together and the scale looks good. And if there's any modifications to the files, then we haven't made, the final part yet. It's just FDM printed, quick, dirty, just get it up on something so that we can look at it. Then for SLA, we use that a lot for high resolution things need to get molded. Um, and each different technology has its, pluses and minuses. FDM is affordable, it's fast for single prints. But you're dealing with low resolution, it's hard to do complex geometries. SLA printing, it's very high resolution, an immense amount of material versatility. I think Formlabs itself has a few dozen different materials that you can run on the Form 3 and 4s. Um, but that technology has its downsides as well. It has a lot of cleanup. You've got resin that you have to wash off, cure, etc. You have to deal with complex geometry when you're actually slicing it, making sure there's no suction points. And then SLS printing, you still get a good amount of resolution, but you don't have to deal with any supports with minimal cleanup, and the parts you pull off are fully functional, strong parts right off the back. So I think Chris is showing right now our kind of lab setup where you've seen this room that we reserve for powder-based printing that has two MJF 540 series in it, as well as a Fuse 1 Plus. And this room is specifically reserved for our powder printing because something you'll see, even on the picture that's on there right now, that Fuse 1 Plus, if you look underneath, you can see a fine dusting of powder there. And this is after I've cleaned the room too. With powder-based printing, you tend to have a lot of powder given off during the printing process. Now that varies per machine, and in this case, the MJF 540s are the culprit here for how much powder leaks everywhere in the room. The Formlabs machine is actually incredibly well sealed, and you'll notice the powder underneath that machine is white, which is the MJF 540 powder. It's not the gray from the fuse machine that it's sitting on. Um, so yeah, when it comes to powder-based printing and how we got into that, originally we had MJF 540s, and there came a time where we were struggling with some mechanical issues within them, and we looked for a stopgap at the time. So, because of how affordable it was and how reputable Formlabs was as a company to rely on their machines, we got a Fuse 1 and we ran Nylon 12 out of it for a while until we could figure out how to keep our 540s from the HP consistent, which did happen, but then we were left with the Fuse 1 Plus, which worked great. Um, and from then, we've kind of adopted it to suit our needs better. So, as you saw in the couple slides before, the MJF build volume is larger, so we use it primarily for these robust parts, whether it's armor paneling. You'll see a lot of, for instance, when we work on Star Wars and we print parts for droids per se. Most of the droid heads are all MJF technology. Their shoulders, chest pieces, legs, all of that is typically MJF technology. And the build volume is significantly larger there. So all these large parts we can print directly, pull them off, finish them, paint them, give them a metallic look, and they work great. They're robust, they hold up on set. We have to build everything with set in mind because the way things get handled, we can handle them as delicately as we want in the shop, but once they leave here and they land on set, these parts have to be able to hold up to all kinds of abuse. So we have the 540s, which is our primary nylon printers now, and then the Fuse 1 originally, we were using it to run Nylon 12, and it did that just fine, but we realized we didn't really need two different sets of machines that run the same thing once we got the 540s up and running. So I can outline some of the pros and cons. Now working with both systems for years now, um, I can go over some of the pro cons of both technologies. They are both powder-based printing, but there is some significant differences between MJF technology and SLS. MJF, which is multi-jet fusion, actually sprays a kind of ink or agent onto powder and then runs a heat lamp over it to center it. Whereas the fuse in traditional SLS printing uses a laser spot to basically laser weld the plastic powder together. So one's using a liquid agent introduced to it and a heat lamp, and one's using a laser. And these produce parts which are very similar in appearance, but have slightly different mechanical properties. So, for example, SLS has the strongest XY strength because as that laser moves across that XY plane and laser centers and basically it's welding plastic to plastic, it has an incredibly high XY strength. But as it's printing, in traditional 3D printing ways, it's printing layer by layer, so it has a slightly weaker Z offset. But then MJF, because it's introducing a liquid agent into this process, the parts you get are actually isotropic, which means they're equally strong no matter which axis. And this is important to us because some of our parts are very large and unwieldy, and they can only fit in the build volume in certain orientations. So ideally, with most SLS and powder-based printing, you orient your parts for their use. If you need something to be strong along a certain axis, let's say you've got this pencil and you want it to be strong all along this axis, you turn it sideways or you turn it diagonally. But with HP's MJF technology, you don't have to worry about that so much because they're isotropic. That being said, like I said before, the SLS printing is stronger on that XY. So if you have a flat bracket or something that you can orient, in a way that you just need it strong across those two planes, then it is going to be stronger on that. And with the machines themselves, they're very different systems as much as their parts can look the same. With MJF, especially the 540 series that we have here, it's an all-in-one machine. It recycles the powder itself. It prints, it reclaims the leftover powder because SLS and MJF technology, they both leftover powder is reclaimed and then reused at a certain percentage of recycled to new. Both of these, if you're running nylon 12, are 80-20. Every time you print, it uses 80% recycled to 20% new. And so the 540 series does all of that within that printer. Everything you see there, all the processes, whether it's brushing off the excess powder back into the build bucket, it's recycling it, it's humidifying it, all of it's done within that machine. Whereas the Fuse One Plus, you have a workflow of several machines, which is you've got the printer, you have the post-processing station, and then you've got the Fuse Blast if you're using that for your post-processing. And this streamlined workflow, I think we have a picture of the Fuse One next to its processing station there. You can kind of see it in the corner, whereas the MJFs just stand alone. So that's the basic workflow right here of the Fuse One Plus is you take your print out, you take the build chamber out, you slide it into the post-processing station, and then you clean off your parts. All that's done in the MJF 540, but in this case, the benefit that the Fuse One Plus has about that is with anything mechanical, the more you're doing in one machine, the more moving parts you have, the greater the likelihood is that something's going to go wrong. So what Formlabs has managed to do with the Fuse One Plus is they've kept it simple. The machine just prints, and the post-processing station does the recycling of the powder, it does the sifting, the reclaiming, all of that. So by keeping these separate, you both keep each machine a little bit tighter on parts, and so there's less chance that something goes wrong. And then if something does go wrong, because inevitably with mechanical things they do, it's a lot easier to fix it, and you only have one machine going down. The MJF technology using the 540 series is great having an all-in-one system. It takes up less footprint. Everything is done in one small area, and it's very hands-off. But the downside to that is, let's say one part of the reclaiming powder or you know, the printer itself, if any part of that goes wrong and that machine goes out of commission, then you have nothing. You have no printer and you have no processing station. Whereas with Formlabs, you have these two very simple machines that if one of them goes down, you still have the other to work on. If your post-processing station goes down, then you can still clean those parts by hand, and the printer is still up and running. Or if the printer goes down, or if you have multiple printers, if the printer goes down, you still have the post-processing station for your other printers. So it's kind of nice the way they have that set up, that just because one thing goes wrong, it doesn't mean your entire system does. And keeping it simpler with the fewer moving parts. Like I said before, it's kind of a understated issue with the fancier the technology, or should I say, the more a machine tries to do, the more things can go wrong and inevitably will go wrong. It's kind of the same reason why me and my assistant, we're both HP certified engineers now. I have the certificate on my wall. I can pull it down later if we need. Um, but because the only way for us to keep these machines running consistently and with as few problems as possible is we had to go and we had to learn how to open the machines up, get inside the guts, how to replace all the different parts, because there's something like 93 environmental sensors. There's all kinds of different systems that have to get maintained on a regular basis. Whereas the Fuse One Plus, it's very simple. There's only the normal maintenance for turnaround for a print to print is about 5 to 10 minutes for us. You check that a few sensors are clean, you vacuum out the inside, you make sure there's no loose powder, and then you vacuum the filters if they're due. It has a great UI system that shows you every so often, every 1,000 layer lines printed, check this, and it walks you through the process on their screen, which is another thing. It is a very intuitive UI. On both machines have a UI that works for their systems, but the Formlabs one, it does a lot of walking you through steps. It tells you when things need to be maintained. It's very clean and very user friendly. Formlabs has always been good about that with their machines. So we really appreciate that and how fast that turnaround time is. So once again, comparing MJF versus Fuse and their applications, one great thing about the MJF is because you have this all-in-one system and you can be, when it comes to the reclaiming and resetting up for the next print, it's all in one place and it's only one machine you have to clean and reset, but it does take a little longer. So to reset an MJF machine, to go through all the different cleaning, and there's a lamp you need to clean every time and take off all the excess powder in the build area. So it probably takes about 30 to 40 minutes to reset an MJF versus Formlabs, which the fuse takes about 5 to 10 minutes. And that's not including also the ability for the Fuse 1 to, you can take out that build chamber, put it in the post-processing station, slide in a second build chamber, and start a print almost immediately within about 10 minutes of another print finishing. Whereas for MJF, because it's done all internally, you have to reset the entire machine for that 30, 40 minutes, and then maybe you need to add more powder, maybe you need to do certain maintenance, so you can't start that print or have a longer turnaround time because of it. So that's kind of a breakdown of MJF versus the Fuse 1 Plus. They both have their pros and cons. The MJF turns out really great functional isotropic parts that we don't have to worry about orienting as much because X, Y, or Z, it all is about the same on there. And the machine having an all-in-one process system means that it takes up less space because each machine is a standalone and you don't need a second machine for that. Whereas the Fuse 1 managed to make two machines very simple and easy to maintain, easy to clean and reset. They take up a little bit more room in the space for two machines, but also it affords you a bit of a scalability factor. With these smaller machines, you can have a bunch of them in a room, whether you need different materials or if you want to add a different post-processing station for, each material needs its own post-processing station. So there is benefits to this kind of modular approach that Formlabs has taken. So yeah, that's kind of an overall breakdown for comparing just the Fuse versus the 540 specific series for MJF. They do have a 5200 series, but that's kind of another beast. And we don't have one here, so I won't try and tackle that in this. So kind of moving on to our use cases for what we use ours for here. And like I said before, we originally got the Fuse 1 to run nylon 12 on it, but we realized we were running two different machines with the same material. So we decided to switch, and first we tried switching to nylon 11 for a little more ductility in parts on the Fuse 1 Plus. But unfortunately, our mechanics, they're used to using nylon 12, and therefore nylon 11 is a little less strong, even though it is more ductile. So parts were breaking and things like that, just because we weren't used to using that material, especially when it looks so much like nylon 12. You can't use them for the same things. So what I ended up doing is seeing that Formlabs had released a TPU powder for the fuse, and that kind of elastomeric material, we use elastomerics a little bit, but I saw an opening for us to move to a powder-based elastomeric and integrate a whole different kind of workflow here for parts. So that's what we did. I ended up changing the Fuse 1 over. Anytime you are changing a powder for a machine, you need to deep clean it. For the machine, it takes about half a day to reset that to do a new powder, whether you're switching to, maybe you're switching from a nylon 12 to a TPU or a TPU to a polypropylene. Formlabs has a great library of materials, and if you do have a Fuse 1, it's very easier for you to break down and see, all right, what is the properties I need out of my parts? Do I need it to be strong and rigid, like a glass-filled nylon, or do I need it to be flexible, like a TPU, or something more like a polypropylene approach? Um, yeah, there you go. There's each of the materials has their own usages, and so we went through nylon 12 here. Then we went through nylon 11 and tried that out. And then we ultimately ended up with what we use currently, which is our TPU 90 powder. Um, and so for those parts, um, elastomerics in 3D printing have been tricky notoriously over time. You have FDM TPU, which is known for stringing, and we do use it here for if we need really quick elastomeric parts. Sometimes we need low res internals that we can generate on our FDM machines, whether it's our Raise Pro 3s or our Bamboos, whatever it is, we can do FDM TPUs, but those have a lot of cleanup. It's hard to pull supports off. And like I said before, it's very low resolution, and you can't really, when we do things here, we need to clean them up to be screen ready. And that includes sanding and painting, priming, all that kind of stuff. And notoriously, FDM TPU, things don't like to stick to it. You can't sand it very easily because of its elastomeric properties. So it's more or less however you pull it off the printer is kind of how it needs to get used. We've developed some ways to paint and body shop these things, but it is a very laborious and hands-on process. Compare that to SLA, elastomeric printing, and then you have parts that are, just to put it bluntly, they're hard to print because the way SLA printing works and pulling away from the FEP or whatever kind of setup they have for the screen, elastomeric parts stretch as you pull them. We call them in their green state before they're cured, which means you have to be very careful about how you print SLA elastomerics. Otherwise, they can tear while being on the printer, or they can pull right off, or they can deform. The parts you can get off them, I know I have some great samples of Formlabs SLA printed elastomerics, and those parts are very strong. And if you make a part to be printed for elastomeric, you kind of have to base your model around the technology you're using. So if you can model a part that works well for SLA printing elastomerics, that's great. But for us, we found that being able to do a supportless geometry on powder-based printing and having functional, strong, robust elastomeric parts was kind of a game changer for us because, and this is where we get into what your parts are being used for. So for us, we can look at how we use things in Fallout per se for the power armor on that case. So Fallout's a great example of how things are traditionally done versus also how things are changing due to 3D printing. So here we've got a picture of this hand that was all originally printed out of nylon 12 on a Formlabs Fuse 1 Plus. So somebody can actually stick their hand in there, and then they have full control of all the digits and fingers, and each of those fingers is made up of like 2 or 3 different parts, and they have inner mechanical workings to this. But as you can see, this stuff can be cleaned up and painted, and it looks screen ready. That's the actual part that they pulled off of the suit there for those photos. So that's an example of, that's just a direct printed part. There's no mold, there's no castings in that. So if we go to the picture of the suits, yeah, there we go. So those suits are a mixture of 3D printed and then molded and casted parts. lots of those, like, you look at the shoulder or the helmet or the chest pieces, um, those parts are made using traditional methods, which is that we print or we sculpt a master, and that's a part. So we sculpt or print this high quality part, and then that goes to our molding department, and they make a mold of that part. And then after that mold gets finished, then they pull castings out of that part. So they'll lay in a polyurethane or whatever you want the material to be. In this case, it was a polyurethane to keep those suits very light and functional. They can run around in them, they can fight in them, they're very durable. Um, so even though it looks like these giant, heavy metal chassis, it's actually very lightweight for how it looks. I mean, I should say it's not super light, but it is for what it looks like. And so that's an example of how traditional methods were used. But then the hands and whatever other, at the time, small parts we could get away with directly 3D printing were made on either an MJF or a Fuse. I think for that project, they were specifically Fuse. And same thing with, we have the Xenomorph hands as well, which uses a very similar system as this. You can see, so yeah, as you can see, the close up here, you've got a breakdown of a bunch of different individual or modular parts all coming together on a mechanical hand so that when somebody moves their fingers down at the bottom, it connects to at the top for it to bend and move organically. So that's an example of how the fuse was at the time being used for these rigid materials out of nylon 12 to replicate these organic hands or whether it's armor parts. And then once we transferred into using it into more like a TPU, we still do these same kind of modular hand parts, but now we get an even greater elasticity and movement out of them because they're not so flexible that they don't work and can't stand up on their own. They still have a good balance between elastomeric properties and rigidity. So we're now using TPU to not fully replace, but to supplement our casting. So like I said before, we have this traditional method in film of making these parts for screen that includes making a master and then making it into we have a something here. Yeah, we have a traditional method versus additive, which is you make a master traditionally, then you mold that, then you cast that, and then you have to finish it, whether it's the flashing you have to cut off of the seam or whatever kind of post-processing those parts need. So every step of that way, there is labor involved and there's material costs because you've got to make the master somehow. So there's your material costs and the time to sculpt it or digitally sculpt it and then print it. Then you have the mold labor and materials, the casting labor and materials, and then the finishing labor. Whereas now, what we're transferring to now is we're able to directly print durable elastomeric parts like those fallout parts we looked at before, whether it's the shoulders or the helmets. Now we can print those parts out of an elastomeric and it functions like a polyurethane casting. And so in that case, you cut out a huge chunk of cost by being able to print and then post-process by your media blasting and then whatever kind of sealing method you use. So it saves time with the mask. It saves time with the molding and casting process. You cut those out, you cut out the labor cost, you cut out the material cost. And in both ways, you're going to have to make either a master or a final product. So for the same method and cost of making the master, you've now made the final print that's going to be used, and then you can jump straight to post-processing. And so there's always going to be a need for traditional methods. It's great for large batches. If you need to make 100 large, like let's say a chest piece for a droid, if you need to make 100 of those, it might be better and more time efficient to make one mold and then be able to pull quick casts out of it. You might be able to pull 3 or 4 or 5 chest pieces a day with this kind of method. Also, you're not limited by the size of your build volume, which would be the alternative. Like the downside to using additive in this kind of case is you're limited to your machine and your build volume. That's as big as it gets. Now, as machines get bigger, we notice that, like, MJFs now have a larger 5200 series. So now you can print larger parts on those, and it's all going to scale up with time, and then we'll be able to print more directly some of these polyurethane castings. So it helps us by cutting out a huge chunk of cost and labor, and the parts are incredibly robust and durable. And I can't state how important that is in film because constantly things break on set. But so far these TPU parts, they've held up immensely well, and we've heard no complaints about them tearing. They have a very good tear strength. They're very durable. So it's a great material so far in our understanding of it. So now I can show you a couple images. We can show you a couple like images of what this stuff looks like before, like when they come out and we straight media blast them. So once you clear off all the armor and the powder, these are the parts you're getting. And this is an old hand plate model from Fallout. Um, so this, you can see that it's a very flexible, and yet we can keep it thin. We can even make, on the right, you see like a poppable surface. So you can integrate whether it's buttons or things that need to look like you can make living hinges, things that need to look like they can move and hold and then pop back, that kind of stuff. And yet it's very durable. We don't have to worry about that being easily punched through or breaking, tearing. It's very reliable so far. And then we get to our sealing process, so that's how they look raw, just media blasted before we've tried to paint them, anything like that. And so what we found is the downside to the TPU powder printing is it has kind of a fuzzy, porous texture that you can't really sand it well, because as you sand it, you just tear it up more to make more fuzz. But in-house, we created a custom heat treatment that not only seals it and makes it smoother, it makes the textures pop back out. At the end here, I'll show some texture samples we've made, but even as you can see on the left, you have the raw part where you can't see much texture on it in the 3D model, whereas on the right, it brings back some of that metallic texture, because that is supposed to be what's in the model. On the right, you see there's a very light texturing over it, and that helps it look more metallic on screen. And then also from sealing it, then it receives paint, and we don't have to worry about it soaking in and how it sticks. Oh, here's a great one. On the left, we have this beaten hammered metal texture that when it was unprocessed, before we had treated it, you couldn't see any of that. But now you see how the light bounces off it, and it has a beaten metal texture as it was supposed to be in the model. And then same on the right, it also creates a glossy finish. So it's important to us for a couple reasons. One, the smoothing out of it means that we don't have to put layers of any kind of sealant on it. There is no added sealing of any kind. We've just put it through our in-house heat treatment. We don't have to add any kind of chemical or layers over it. That is just our quick heat treatment, and then now suddenly it's sealed, it's smooth, and it brings back out the texture to the surface. Yeah, so as you can see, these TPU parts, they're gaining more traction here. We're using them more and more for every project. If you go to our website, you can see that we have two upcoming projects, which is the Superman film and the Mandalorian and Grogu film. And I'm excited for you guys to finally get to see what we've been using, what we've been cooking up here in our lab with the TPU powder for those. Um, I'm sure once that all comes out, and then we can talk about, which assets those were. But it's been really great to be able to directly print parts for these films and be able to do them quicker and even stronger. And with this quick process that we have, that Formlabs has enabled with the Fuse 1 TPU powder for us, it's been a real game changer for elastomerics. There's such a hesitancy to use elastomerics because either they're seen as too weak, with some SLA elastomerics, they tear very easily once they start, whereas this stuff has such great tear strength. It keeps a good amount of resolution as well. As you can see, it's bringing texture to the surface. Um, so we're able to make that into the 3D model. So yeah, TPU's done a great job of enabling us to generate cast-like parts um, on a much more efficient timeline and budget. Um, so that's overall a breakdown of how Legacy Effects uses TPU powder-based printing in our process. We've only had our Formlabs machine for a couple of years, and for a lot of that was Nylon 12, and we were excited, and it was very useful as it was then. But now switching to something we had never even had before, a TPU-based powder, um, we only started on that within the last couple of projects. So I'm very excited to see what you get to see when those come out, and yeah, the Fuse One has been a great plus for us to supplement our print farm. We've got a few dozen printers here, and you know some of them are more broad. Like we've got a bunch of FDM printers, and they can all be kind of used interchangeably, whereas there is nothing we have that does what the Fuse One does with TPU. That powder, there's nothing else that can enable those kind of supportless geometries with minimal cleanup and strong elastomeric properties. We don't have anything like that but this. So it's been a great boon to us, and we look forward to using it more and more in the future, and growing our fleet and seeing what more these machines can do.
Yeah, that was great. Thank you, Sam. I especially appreciate the candid pros and cons of us versus competitors and how we fit, because obviously the best labs are always going to be the ones that have the most options. So you're not having to rely solely on one system to try and do everything, because not, there isn't the perfect machine for every single application
Yeah,
out
every machine has its strengths and strengths and weaknesses.
there. Yep. Okay. So some closing polls here. Should be a second one popping up on your screen shortly. Uh, what is your biggest barrier in getting started with 3D printing? And then second question, it's more of a Formlabs question, is would you like to be contacted by a Formlabs product expert? That will allow you to get the latest and greatest information from our sales reps, sales engineers. If you want to go through specific projects, if you want to see how attainable or cost effective it might be, that's going to be your best avenue to get that information figured out. For everyone that has attended today, you will be able to request and get a free sample part. Nylon 12, Nylon 11, TPU, polypropylene, all of the materials you will have available for those free samples. If you want to just see how they feel, check the texture, whatever it is. We also do now have the polish samples, which are really cool. That's the add-on that we have on the Blast. And then for those that are looking to get more information from Legacy Effects and Sam, there is some emails on the bottom right, and then afterwards we'll send you, direct contact information, website, Instagram, whatever it is, so you can see all of the cool stuff that they're continuing to make. So Q&A, and then I think Sam, you had a couple parts to show off as well. So
Yeah.
let me stop sharing my screen so you can get into the big picture and you can show off those parts, and then I'll start funneling through the Q&A and we can get that sorted.
Sure. now that you mention it, I actually do have that polished part right here for we're looking at getting a fuse blast here. Um, because what's great about that machine is also it's not just for fuse machines. It can do any kind of machine that you have existing in your shop, whether it's SLS or MJF. The fuse blast works with that. So it's got the unfinished part and that polished part. So it's a great sample piece they've got for that. So I've got some pieces here that are kind of good examples of what we use the different technologies for. Um, so FDM, like I said, we print things very quick and dirty, like to scale. So this is a part of a xenomorph jaw that's FDM printed. It looks decent resolution, but if you really get up there, you can see all the layer lines and where the support contacts were. Um, Example of a SLA printing would be, oh, actually, here's a great comparison between SLA and the Fuse TPU. So traditional methods, like we were talking about before, is this is a texture sample that we made. Um, Traditionally, you would print this, which is a high textured part here, and you would print it, you'd make a mold of it, and then you'd cast it out of whatever polyurethane or silicone or whatever you're using. Whereas here's that same part that is already ready to go. It managed to still keep the texture that's on there. I don't know how close I can, you can see that it's kind of got a nice glossy surface. It carried over that texture. And this is just a ready to use functional part right off the printer with our sealing process. So, from this to get this to a wearable piece like this would go through, mold making, casting, cost a lot of time and labor. Whereas now we're just able to directly print these parts and it's ready to go on. It looks great, has a good finish, can take paint very easily, and it's ready to go. But that's an example of also what we use SLA for here. If we need to print, well, for example, like this same xenomorph, whenever we made the full head for it, the jaws or all the different creature aspects all over it, then we would be able to just print it out on our SLA printers. We have a variety of different brands here, and they all do different kind of things and whatever kind of resin we need to use for it. Um, but yeah, we do high resolution stuff that goes to mold typically with our SLA printers here in house.
Cool. So just in an effort of time, let's make sure we get through some questions.
Yep.
We had a couple questions surrounding part shrinkage, tolerancing. Do you have to create different scales if you're printing on MJF versus the fuse,
Yeah.
maybe material by material, things like that?
Yeah. So a good example of that, for MJF versus Fuse, our mechanics have been so used to modeling, whether it's bolt holes or wire pass-throughs for MJF, which they account for MJF by accounting for expansion. MJF material, even if we're talking to the microns here of how much it's expanding. Usually they're all very good tolerance, but there is a minimal amount of expansion with MJF. As this liquid agent is added, you actually find that the parts are just barely larger than the model. Whereas with the fuse, with laser sintering, we actually ran into the opposite. Because of the heat from the laser and how it interacts with welding the plastic, you actually get slightly smaller tolerances. So let's say you have a bolt hole that is, 0.1 inches wide. On MJF, maybe it's 0.1001, so it's expanded a little bit. Whereas on the fuse, it might be 0.00 or 0.9999. It's like slightly, ever so slightly shrink. So that's the difference between MJF and SLS is MJF expands a little bit on the micron level and the fuse actually shrinks a little bit. But both of them are very good tolerances for the most part. We have no issues with, once we factor that into the model, there's no issues with tolerances.
Yeah, the big thing is as long as it's repeatable, it's a
Mhm.
one-time fix, and then it's, continuous.
Yes, and there's once you find what that number is, whatever that shrinkage is, it's consistent amongst every print.
Mhm. And you have not run any other materials besides the Nylon 12, correct? On your HP? You haven't tried the TPU?
Our HP 540 series only runs the Nylon 12. I know their 5200 series has different options, TPUs and all the different materials, but that's not what we can do on our machine here.
Understood. We had a question on, so obviously as you're making larger assemblies and things like that, combining maybe additive parts to injection molded parts, casted parts, whatever it is, what is your kind of best tips and tricks when it comes to welding parts together, adhering parts together? Is this friction welding, adhesives? What's your preference?
Primarily, I think one of the best ways that we have found to adhere things is using, I know JB Weld is used a lot. That bond is really strong and we trust that. Though a lot of our stuff is fastened mechanically too. Um, whether it's we model in behind the part, mechanical bonds for like bolts and screws, things like that to go through. But when it comes to adhesives, I know that we use a lot of JB Weld. Cyanoacrylic glue is used a lot, though that depends on, it works actually really well for the TPU powder, but it doesn't work so well for TPU printed FDM. It just doesn't stick to it very well. And same with SLA. It doesn't stick very well to SLA printed elastomerics, but JB Weld typically does. And there's a few other chemicals we use in here. I can't remember offhand, but I know those are primarily the two. And basically it goes with, we try cyanoacrylic glue, and if that doesn't work, we go to JB Weld, and that for sure will.
Cool. Can you say anything more on that heat treatment, specifically the TPU, or is that a internal trade secret?
Uh, Basically, you're exposing it to a high level of heat for a short amount of time. Um, because what you're essentially doing is lightly melting away that fuzz that's on there. Because like I said, it has almost a felt-like texture. I don't know if I have any raw parts. Yeah, actually, here's a good example of it. So here's once again, I don't know how well it'll focus, but there's a raw part here versus a heat treated part here. And you can see a slight color difference, but we expose it to a large amount of heat for a short amount of time, and then it seals up, and it brings that texture back out. I know I can't show on this camera very well, but the photos that are in the slides are pretty good for showing how much texture you can get out of that heat treatment.
Yeah, I'm curious to see how that treatment would compare to more traditional vapor smoothing, where it's chemical abrasion as opposed to like mechanical abrasion on the fuse blast polish. So it's cool that you're able to do that all in house.
Yeah, and it's very quick, and we don't have to add any chemicals to it, which is a big thing for us with all the different paints and primers we use. We'd like to not have to add a bunch of sealants on top of that to interact with that.
And that's just squishing down the surface, correct? It's not really like eating away at, you're not concerned about tolerancing or wall thickness.
No, it's eating away. Yeah, it's just like you said. It's just affecting the surface. It's not changing anything. It can, if you keep going for too long, you can end up, like I said, this is a large amount of heat for a very short amount of time. It's very brief. Um, but because you can, in our testings we did, start melting away parts. So you have to be a little careful about it.
And then regarding nylon 12 parts, or I guess in general, getting parts screen ready besides um the heat treatment and things like that, what sort of, I guess, more generic post-processing techniques are you doing?
Yeah.
Certain
So,
sprays, paints, any preference there?
yeah, so nylon 12, much whether it's MJF or SLS, we use a kind of poly priming chemical, which is a primer and a filler, all in one. So first, we'll hand the part over, and I have a giant. Oh, here's a good one. So let's say this is an MJF part, and it's just gonna sit on a droid armor somewhere. Um, so first, after I media blast it, then it'll go to well, one of our other guys will go to a sandblaster and blast it additionally to kind of smooth out, to use an abrasion to kind of smooth out that surface texture. And then if it's a smooth part that needs to look flat and metallic, then they'll use some kind of poly priming on it. Um, and then sand that down. The traditional, if you see any layers, You prime it, you fill it, you sand it back down until it's perfectly smooth, that kind of thing. But with parts that come off of an SLS machine, they're already significantly smoother than what you would get off of an FDM machine. Um, so it doesn't require a whole lot of post-processing in terms of that. The paints, I'm not sure because I'm not one of the painters, so I can't tell you what paints we use. I know it's a collection of different things like acrylics and automotives, all kinds of different paints for different applications here.
Another question that goes into more of the financial and time. How do you go about calculating what is more cost effective? 3D printing a small batch or going to the master mold and casting? What's the sort of big point?
Because we don't have like repeatable production end-use parts that we're printing in batches here, it's kind of hard to ever do a complete breakdown of a cost per part, but it's usually pretty obvious to us. If the simple answer is if we can print it, we print it. There's rarely a case that if we have the option to print it and use it directly as a functional part, that we don't do it that way. But we're bound by volume and size. For example, the Fuse One Plus is, I believe, a 6.5 by 6.5 by almost 12 height. So you can't print, a whole helmet in there. You can't print a whole chest or armor plating piece. So those we'd have to go through traditional methods. Whereas if we can get away with it, hand plates, fingers, small leg parts, anything that can fit in the build volume and it needs to mimic a polyurethane casting, we print it. Because it cuts out, to make a mold of something, uh, let's say even this texture sample, it takes a day to make the mold. And that's just for a small part. If it's a large, complex matrix mold, maybe it takes 2 or 3 days to get to clay it up and mold both sides of it. And then you have to cast it for another couple days. So you've got labor cost. You have a person working on that for 2 to 4 days. And then you finally have one casted part that then you need to trim the flashing and do any other cleanup for that. Whereas with a printer, if you can put it on there, you put it in overnight, and then the next day you pull it out, you bead blast it, and it's pretty good to go from there.
And what's your usual turnaround time once you get a bid or whatever accepted to make this suit? Obviously, it can vary, but what's like an average turnaround?
That's the hardest question you asked today because there's no simple answer. When we get a bid for something for a project and we get onto a project, there's some things in mind, whether it's, for example, in let's say Mandalorian, back on season 1, we might get a bid to make the Mandalorian armor, and then while we're working on that, which we have months to do, something happens in production and they go, hey, actually, we kind of need this small little creature as well. Could you guys do that? And then so things will pop up while we're working on projects and things get added on, things get changed. You might get something almost all the way to completion, and then because of them changing stories like in the script writing, or something else happens in the production where now either maybe that thing is no longer needed, or maybe now it's a hero role. Maybe a background character you were working on is a hero role, which means you need to go back, you need to clean it up more, you need to add added functionality. So we make animatronics, and a lot of them, if they're more background, they don't do a whole lot, they just need to move simply around. Whereas if you look at Hu Yang from Ahsoka, that's an animatronic robot that was a hero character that we had to add all kinds of functionality to it, whether it's spinning, talking, emotional reactions on the face. And there's a lot more that goes into those. So with any project here, it changes on the fly, but usually we try to give it a few months lead if we have a large part to make.
Yeah, but it sounds like 3D printing is going to be the relatively cheapest and quickest way to be agile as projects change and
Oh, incredibly. It allows so much agility for that kind of thing, so much ability to pivot because, if you had a traditional sculpt of something and you mold it, you cast it, you have a final part, right? And then suddenly they go, actually, we don't want that, we want something else. Well, now somebody has to sculpt something entirely new, and you go through the whole process again. Whereas if it's a digital sculpt, you can tweak things on that much more rapidly and get a new iteration out almost immediately, and then print it overnight. And there you go. You've got your part in weeks earlier than you would have using traditional methods.
Great to hear. One last question, because I know we're at time. Uh, Formlabs does not have a FDM printer. No plans to make one. Sam, you mentioned you own a Bamboo. Do you enjoy it? Any preferences? Any thoughts there?
For printers in general, or for FDM
For
specifically?
FDM specifically. Again, we're hitting the
Um,
whole spectrum here of 3D printing.
yeah, we've got I would say, and I know this just sounds like I'm repeating what everybody else is saying in the industry, but the bamboos are, whether it's commercial or prosumer or industrial, they're an incredibly reliable and fast machine. That can print with a lot of different materials. We print mark forged onyx carbon fiber filament. We throw it on our bamboos to print it because it's faster and it turns out great quality. So yeah, for FDM, those machines have their speed and resolution for an FDM machine is pretty astounding.
Yeah, I've heard the same and always been very
I know it
positive.
sounds like everyone's saying the same thing, and I don't mean to be a broken record, but the machines are really good. They're, of course, limited by size. We have bigger format machines for FDM when we need to print like an entire alien head and don't want to break it into 13 parts. So we have larger format printers that work just well. Um, but I'll be curious to see as all these technologies get faster or bigger or what comes out of these, both FDM, SLS, SLA. I know you guys made a huge leap forward with speed with SLA printing with your Form 4. Um, Something that we had had an eye on for a long time because traditional SLA with the laser, while a good resolution, it takes longer to print. But that Form 4 it looks incredibly fast. And from what the parts that I've gotten samples from, I have really good resolution.
Mhm. So we are over time. Uh,
Hmm.
any leftover questions or comments that are still left over, we'll follow up via email. Sam, thank you so much for your time.
Of
For
course.
the participants still here, we appreciate you. We enjoy you having you here and learning more about Foam Labs and our great customers. And that's all I got. I want to wish everyone a great afternoon, night, wherever you may be. And that's it. Bye, all.